Okay, in this video we're going to take a look at the Maclaurin series. This is called the Big 7. This is a really cool topic. So, learning goals. Students will be able to know what a Maclaurin series is and how to use the Big 7. So remember, a Maclaurin series is just a Taylor series centered at 0. So let's go ahead and just dive into it. Now, you can come up with these each time by doing the Taylor series and centering around 0. Or you can basically memorize. I know that's a bad word to you, but those of you that made it this far in mathematics know that using the Taylor is kind of long and tedious sometimes. So basically, if we memorize this formula, like e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 x to the n over n factorial plus dot dot dot. This is the actual expansion of the Maclaurin for it. These are the 7 that are most commonly seen on different exams. So the Big 7 saves you a lot of time. Now, a lot of people just memorize this right here, and then they come up with a general term on their own. So the general term, I put an x on top of it. That's kind of tough to do for some people, so I want to at least give it a go here with you. You can see here that the pattern, basically, the general term would be, okay, the top has an x, and it looks like I'm increasing from x to the 0 power, x to the first, x to the second, x to the third. So that would mean that I would have an n here. And the denominator, it looks like I'm increasing in factorial, so that would be n factorial, and then basically that would be your general term. This is the actual series. It looks like I start off at 0 and I go to infinity. So the series for e to the x is equal to this, what I just wrote for you, sigma from 0 to infinity. If you're like, I don't get it, why do I have 0? Well, if you have x is 0, that's 1 over 0 factorial. That gives you the first term. If you go to the next one, 1, okay, over 1 factorial, well, sorry, x to the first over 1 factorial, you get the next term. If you plug in a 2, so forth, so on. So the general term is very, very useful. Okay, let's read through them, and then we'll see how they work. Okay, so for sine x, it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, on and on and on to the general term and on even further. Now notice this general term is a little bit trickier to come up with, but it's still doable. You just got to see a pattern. And if you notice that we always call sine the odd function, and it's for a good reason. Look at the expansion of this thing. The Maclaurin expansion, we have all odd exponents. It's pretty cool. Cosine is an even function, and look, we have all even function exponents. That's equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, on and on and on. Now notice what you can do here is this. If you want to memorize these, if you know e to the x, you can basically generate sine and cosine. So what I mean by that is this. If sine is the odd function, if you write out e to the x and just pull out, let me use my marker here, a different color, you could just pull out all the odd ones out of e to the x and just make them alternate. And look, that's what sine is. Okay, now that has nothing to do with sine and cosine, but it's just a way to memorize. For cosine, same thing. You can pull out all the even exponents and then alternate them in sines, and that's what you would get. Another important one is arctangent. That's x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7, on and on. 1 over 1 plus x, that's a really strong one as well. That's just 1 minus x plus x squared minus x cubed. 1 over x itself is a good one, and 1 over 1 minus x is a good one. So those are the Big 7. I would say memorize them if I were you. It makes life a lot simpler. Okay, so here, once you spend some time with those and you memorize them, let's come up with them, not using the Taylor, but let's just center it at 0. Let's just write them out. Sine x is equal to, okay, so I've memorized these already. I know they're odd powers. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot 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 plus the general term. Now I know it's alternating, so I write it -1 to the n power, and I know they're alternating, well, they're all odd. So basically it would be x to the 2n plus 1 power over that same power, but as an basically as a factorial, plus dot dot dot. So the general term, you really got to look at the rest of the terms to figure this out. You'll get really good at it. I can do it kind of quickly now because I've been doing this for a while. So cosine x is equal to the even power, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And you can check me. You have the notes hopefully in front of you. Minus x to the 6 over 6 factorial plus dot 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 plus, okay, it alternates, so negative 1 to the n. And then here it's even, so it's just going to be x to the 2n power over 2n factorial plus dot dot dot. Okay, so I know I'm making this look easy. You will too if you practice. The next one, from memory, it's 1 minus x plus x squared minus x cubed plus dot 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 plus negative 1 to the n power. And it looks like they're just going up in degrees, so x to the n plus dot dot dot. Okay, so let me ask a question. If, let's say, I want to get rid of this 1 here, what would I have to do? I'd have to subtract the denominator by 1. So that means I would plug in basically an x minus 1. So watch what happens. If we take this same series here and we put in x minus 1, what happens here to the left side? It's just the 1's cancel out, and I would just be given 1 over x. So the beauty and the power of the Maclaurin series is you can manipulate it. So if I replace every x here with x minus 1, I actually get 1 over x. So that would make 1 minus x minus 1 plus x minus 1 squared minus x minus 1 cubed plus, and if you see the pattern, it's going to be negative 1 to the n because it alternates, x minus 1 to the nth plus dot dot dot. So there's my general term right there. And notice, if I just memorize 1 over 1 minus x, I get 1 over x for free. Okay, so let's try a couple more. I know it doesn't click for a while. So instead of writing sine 2x, let me first write sine x, because I know what that is. That's just x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot dot dot. Okay, so what I'm going to do here is this. I'm going to grab another color, and I know I'm speaking fast because I get excited when I do these. This basically, I can manipulate this Maclaurin by just substituting in a 2x everywhere I see an x. So that would make 2x minus 2x cubed over 3 factorial plus 2x to the 5th over 5 factorial minus 2x to the 7th over 7 factorial plus dot dot dot. So there it is. I didn't have to do the Taylor centered at 0. I could just use something that's similar and reevaluate the x's. Okay, let's try the next one. I'm going to find cosine x first. That's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial plus dot dot dot. Okay, so I'm just going to substitute all the x's in with x squared. What that would look like is this: 1 minus x squared squared over 2 factorial plus x squared to the 4th over 4 factorial minus x squared to the 6th over 6 factorial plus dot 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 dot. And I'll let you practice finding the general terms. We don't have time for that in this video, but really neat, isn't it? And the general term here, you know, for x sine x, hopefully you don't know it for sine 2x. And to do that, don't try to plug in, try to look and see the pattern. Okay, so we have time for one more. So what I want to do is this, well, maybe two more. If I write out e to the x really quickly, I can do this problem. So it's 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial plus dot dot dot. And so all I would do here is I would replace x with negative 3x. So that would make 1 plus negative 3x plus negative 3x squared over 2 factorial plus negative 3x to the fourth over 4 factorial plus dot dot dot. Okay, now we have time for the big one. Now, it says here, show that the Maclaurin series e to the x, like the function, it repeats. Now, what I mean by that is this. If I take the derivative of e to the x, I get e to the x. If I integrate e to the x, I get e to the x. So let's show what the Maclaurin expansion is. It's 1 plus x squared over 2 factorial plus x to the fourth over 4 factorial plus dot 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 x to the n over n factorial plus dot dot dot. Okay, and don't forget your ellipsis here, dot dot dot, 3 dots. Okay, so if I take the derivative of both sides, let's see what happens here. If I take the derivative of the left, I just get e to the x. If I take the derivative of the right, so this whole thing, let's see what happens. You get derivative of 1 is 0, plus derivative of x is 1, plus derivative of x squared over 2 factorial is 2x over 2 factorial. Those cancel out. Plus, in this case, 4x to the third over 4, and I forgot my factorial there, 4 times 3 factorial plus dot dot dot. And these cancel out. So guess what happened? You just regenerated e to the x. So you get 1 plus x, and then, let's see, this should be, oh, look at that, I'm missing, I was rushing. This should be x to the third over 3 factorial. Squeeze that in there. So if I do that derivative, I get 3x squared over 3 times 2 factorial. So that gives me my x squared over 2 factorial plus x to the third over 3 factorial plus, and you guessed it, you'd get x to the fourth over 4 factorial. So be careful when you're expanding it out from memory. I'm just rushing to finish before 10 minutes, but that's why if you take the derivative of e to the x, you get e to the x, because the Maclaurin expansion just gives you the same thing back. Kind of neat. And also if you integrate both sides. Alright, so we are short for time. It says students will be able to know what the Maclaurin series is, just Taylor centered at 0, and know about the big 7. I would memorize them. They're a huge tool and they save you tons of time. I'll see you in the next video.